we'll come back to you later, definitely at the discussion.
Okay, thank you.
So Erik Zilman, he's representing Planet in this webinar, and also talk about the capabilities that they have for agriculture. Erik, the floor is yours. We can't hear you yet, Erik.
Yeah, the unmute button was hidden behind some applications. So I hope you can hear me now. Yeah.
Yes, yes.
Okay, cool. And yeah, so first I want to say hello and welcome to the audience. Good to see so many people are interested in this webinar. And second, of course, I want to thank the organizers of this CAPIGI webinar series for inviting Planet to talk about our approach and unprecedented capabilities of providing high spatio-temporal insights into field management activities and crop status. So my name is Dr. Erik Zilman, and I'm working as a solutions engineer at Earth Observation Specialist for Agriculture at Planet. And so I will start with my presentation. Oops, what is going on? Okay, so when it comes to monitoring of crop health and field managing activities, temporally frequent information across the season is crucial to potentially detect any growth anomalies timely or to assess the compliance of management activities to existing regulations. When farmers or authorities missing information in key moments during the growing season, they are acting on an incomplete picture. And data that provides enough spatial detail and show variability within the field, as well as to assess management activities on small parcels is required. Another aspect in this whole context is data consistency. Temporal and spatial data consistency is very important, and to derive analytic results you can rely on. Within agriculture, that means it's vital that what's being measured in a time series of data is related to real changes that are happening in the field and not to any shifts between different sensors. And last, the solution needs to be cost effective with a return on investment to make the technology and platform a worthwhile endeavor for the customers. We at Planet have built a satellite constellation that is capable of serving the agricultural business with the right data to accelerate its digital transformation. Our mission is to image the whole world every day, making change visible and accessible and actionable, of course. Okay, so these are the main components of features of Planet's monitoring solution. Our always-on satellite constellation collects imagery over the entire landmass of the globe on an almost daily basis. You do not need to place a tasking order, as you heard before in the presentation, and then wait days for the delivery. No, our satellites are always capturing images, and this saves you time and effort, and the imagery is always available when you need it. Almost daily monitoring at 3-meter resolution ensures an up-to-date field level overview of field management activities, and near real-time information allows you to detect and respond to changes in crops as they occur. All data collected is published in Planet's cloud-based platform within 24 hours after it has been captured, and can be easily accessed via our online GUI or through our APIs to pull the data directly into the tools and workflows that you are using. So here you see on the right side one of our Planet satellites, the so-called DARF. It's about the size of a shoebox, 10 by 10 by 30 centimeters, and it's just 4 kilograms. So we built our own satellites in-house, and we are constantly innovating and incorporating the latest technology into these small satellites. They are all capable of capturing spectral reflectance in visual and near-infrared spectrum at 3-meter spatial resolution. And our most recent version of the sensor provides an additional red edge band, which is especially beneficial for detecting vitality change in vegetation. and more additional bands will come soon within this year. Additionally, we have a constellation of 21 SkySat satellites, which are capable of multispectral imaging at 65 centimeter ground sampling distance, which allows us to generate an image product with a 50 centimeter pixel resolution that provides a very detailed insights almost on crop level. This constellation is a traditional tasking system, which means we start imaging your AOI as soon you send us an order. Sorry. So this video shows you how our constellation works. So we have launched more than 100 of our nanosatellites to create a constellation operating like a line scanner of the Earth rotating underneath, capturing images everywhere on Earth almost every day. All these satellites are operating on a sun-synchronous orbit with a relatively fixed acquisition time every day. And the 15 of our SkySats are operating on a sun-synchronous orbit as well, and 6 on a more inclined equatorial orbital plane. For those 6, the acquisition time varies from day to day, but the benefit of this orbit is that it allows us to capture individual locations on Earth on a sub-daily basis. So between 7 and 10 times a day is probably possible. Around crop production and field monitoring, satellite imagery is basically beneficial for supporting various crop management decisions and identifying management activities throughout the entire crop cycle. Delineating management zones in fields, for instance, is essential first step in planning the seeding density and the application of inputs. Vegetation indices calculated from historical imagery, for instance, can be used to create baselines for in-field variation of crop productivity, which helps agronomists to set site-specific crop production goals and recommend addressing different parts of the field in appropriate ways. Furthermore, this kind of information can be helpful to farmers in case they want to engage with financial institutions. Better justifying the farm's productivity potential is helping banks and insurers to better understand and evaluate the risk of their investment and to arrive at the fairest financial terms, for instance. Early in the season, soil brightness maps provide insights about the relative spatial variability of soil properties within a field. Those are mainly associated with average water holding capacity, soil type, or organic matter content. This information can help to better inform the decision of what variety to plant in which part of the field and to decide about the appropriate site-specific seeding density. Additionally, it allows for assessing field managed activities regarding the implementation of certain soil conserving management practices, such as the presence of cover crops or non-till planting, for instance. Frequent crop monitoring across the growing season enables farmers and advisors making better informed management decisions in almost real time as conditions change on the ground due to factors like weather, nutrient supply, pest or disease infestations. High cadence imagery allows for tracking field management activities across the season, which makes it possible to determine tillage practice and dates, as well as narrow down, for instance, grassland mowing dates. In the framework of the CAP subsidy control, for instance, this enables the paying agencies to assess the compliance of field management to the rules and practices farmers are obliged to. In the past, farmers often spent hours conducting systematic surveys of entire fields to locate and identify problems. Maps generated from up-to-date satellite imagery can quickly and accurately guide farmers to affected areas in the field, making field diagnostics much more efficient. These kind of maps can serve as well as a basis for generating variable rate treatment prescriptions to support in-season crop management activities such as fertilization and pesticide application, which requires site-specific treatment decisions at specific key growth stages. And at the end of the season, knowledge about the crop senescence level of different fields helps to better manage harvest operations. Vegetation indices sensitive to those variations in crop senescence provide the ability to map crop drying patterns within fields, helping to guide site-specific determination of kernel moisture content and updating the harvest priorities. So what's coming next? All our technological improvements are aiming on providing more reliable and radiometrically accurate spectral insights, as well as making dense time series analysis a less challenging endeavor for our clients. So we are adding more spectral bands to our sensors. I've mentioned that earlier already. So we have recently developed a new sensor to be more compatible with public data sets from Sentinel-2. As you can see when you're comparing the spectral response curves of the Sentinel-2 in the top row with those of the SuperDove at the bottom. So that's a new name of our sensor. That's SuperDove instead of Dove. We have tightened our bands to make them more sensitive and aligned with Sentinel-2 and added additional spectral bands. All satellites launched in 2020 and the ones we are launching in the future are equipped with this new sensor. By the way, the next launch is scheduled for, I guess, for tomorrow, and we are placing 40 or more than 40 additional satellites in orbit tomorrow. Yeah, this is a very important technological step for our users, since this is enabling them to apply the same algorithms that they use for Sentinel. They can apply on top of Planet data now as well, with doing only small adjustments to the thresholds or so that they are using. Yeah, okay, so this is just another slide to show you which bands we have added. Currently, we are delivering 5-band satellites, satellite imagery, so with the RGB and near infrared and the additional red edge band. And within the next few months, we are providing 8-band imagery with the additional green band, a second green band actually, a yellow band, and the coastal blue band. So with these additional green, yellow, and red edge bands, you will be able to do more advanced spectral analysis and gain even more detailed insights into plant health. So yeah, and a second technological improvement we are very excited about, and that is coming soon also, I hope in the first half of this year, is our Planet Fusion monitoring. Planet has implemented a method called SESTEM in order to enhance and harmonize the radiometry across the entire fleet of our satellites by leveraging rigorously calibrated, we call it gold standard satellites, such as Sentinel, Landsat, and MODIS as a radiometric reference. The final product features the radiometric and spectral characteristics of those public data sets in synergy with the superior spatial and temporal resolution of our Planet Dove satellites. Fusion is not only improving the interoperability of the different sensors within our constellation, it also increases the cadence of useful imagery by providing a gap-free daily data stream. To achieve this, we are using a machine learning-based prediction models to predict the missing values, because of cloud coverage, cloud shadow, or missing data at all. So this short video visualizes on the right side the challenges working with multi-sensor data streams. This is highlighting spatial and temporal inconsistencies due to cloud coverage gaps and the fact of having sensors with different spectral response curves and band characteristics. And on the left side, you see how it looks after this fusion processing to create a clean, radiometrically harmonized surface reflectance data feed. So because Fusion provides a robust and temporally consistent surface reflectance data, it is capable of producing data on crop phenology that is remarkably accurate to readings from ground sensors. Planet Fusion data can be used to accurately locate specific key crop development stages across the entire life cycle of the crop for making timely decisions about pest management, fertilization, and irrigation, for instance. And it also enables paying agencies to track all field management activity across the season, which makes this project a perfect match for all CAP-related field control by monitoring activities. We at Planet think that this fusion will be a game changer for imagery-based near real-time agricultural analytics. With Planet Fusion, we are going to provide an analysis-ready data stream which removes friction of cumbersome pre-processing and reduces the burden of data integration at our customers. So with a Planet Fusion product, we will this Planet Fusion product will probably released by, I hope, by mid of this year, so it's not 100% sure when this will happen, but stay tuned for more updates that are coming soon. So with this, I have reached the end of my talk, and I want to thank you for your attention. And in case you are interested in learning more about Planet, about the fusion monitoring, or how to get access to our imagery, just reach out to us. And with this, I will hand over to first probably Tamme, and then to Elise. So thanks for your attention.
Thank you very much, Eric, for your insights and showing what's coming next with this fusion. That seems very exciting. Yes, before we go to Elise, I think we have some technical questions in the Q&A that I saw. There was first of all a question, I think that's for both Benjamin and Eric, about the cost of those imagery. And now I know that the commercial aspects of selling imagery is not very easy to explain, but maybe you can explain what kind of customer groups you are targeting with these data. Are you thinking of farmers, governments, other agencies? Maybe Benjamin first and then Eric.
Okay, yeah. The cost, of course, depends on the resolution, which is 30, 40, or 50 centimeter, and the band combination, which can be black and white and up to 8 bands, or the sphere as well. But it varies around $17 up to $30 per square kilometer. And regarding the groups, we do not forbid anyone to buy satellite data, of course. Our main targeting groups are governmental institutions, but we also have the farmer in northern Germany who wants to monitor his field. So it varies. Also, academia and research is a big partner from us. So I can't really say that we have one target group. Of course, for 8 bands, the target group is agriculture, but I can't really say that some group we exclude some groups, or so anyone.
Okay, thank you. Eric?
Yeah, actually, I mean, our client database is also covering, various industries. So it's, let's say, insurance, business, forestry, all governmental organizations, NGOs, research as well. And of course, we're targeting, or the idea of this constellation at the beginning was, of course, providing an appropriate data set for the agricultural business. And this is, of course, one of our biggest customer groups. Regarding the pricing, it's difficult to disclose a square kilometer price, because that is also varying a little bit depending on the amount of data that the client is ordering. So, if he wants to monitor 100 hectare or 1 million hectare, that has definitely an influence on the pricing. We have different price models. So you can subscribe, for instance, for getting imagery for the entire year for your field that you want to monitor, or you buy only, I don't know, few data sets across the growing season, and this will also have an influence. But if to get more insights on the pricing, I would like to ask you to get in contact with our salespeople, and they can definitely discuss the pricing in more detail than I can do now.
That's good. Thank you. Thank you very much. Another question, a few questions about the cloud cover. I think you both explained that you have a lot of revisits or accesses, as you called it, Benjamin. Can you say something about how to deal with cloud cover? And particularly, as we see in the Netherlands, we have some periods in the year with persistent cloud cover of at least 2 or 3 weeks.
Yeah, unfortunately, yes. So, well, with your eyes, you also can't see through clouds. That's a physical fact. So actually, with atmospheric compensation, you can get rid of the haze in a certain degree, but we can't get rid of the clouds. And with our revisit time, of course, we try to cover the AOI then as cloud-free as possible. But yeah, a certain amount has to be accepted, especially over areas like in Northern Europe. And if you go to the coast of Libya, you are lucky, but you can't plant any plants there without irrigation. So yeah, I think I read the question, but there is no tool to get rid of clouds before we acquire an AOI, unfortunately.
And Eric,
Yeah,
is your fusion approach a way to get around the clouds?
Yes, so but let me start first. So our approach was, with having this constellation capable of imaging a location or the whole landmass every day, the idea was to increase, of course, the cadence and to increase the chance of having an image when there is a cloud-free day, right? So if you have you said a persistent cloud coverage of 3 weeks, okay, of course, then our constellation is not able to get a cloud-free picture. But if there is one day in between with no clouds, then we should be able to get an image. So that is one approach to come around or overcome this issue. And yeah, this fusion product is actually, the idea is also to predict values for cloudy days. So and you all can imagine this is probably a very quite simple, no, not simple, but a task that can be accomplished if there's a gap of a few days. Because we are using data processed backwards of 1 year or more to better inform this prediction model. So it works quite well. But yeah, if you have a gap of 3 weeks, the predicted values become more unreliable the longer the gap is. And of course, also the higher the dynamic on the ground. When you think about a forest where nothing is going on, the predicted values are definitely reliable. But in a time frame of 3 weeks, if something is happening, like a bark beetle infestation in between, we will probably not be able to pick up the right date, right, when that started. But it's definitely an improvement, and it will open up completely new ways of analytics, of time series analytics.
Okay, I will have 2 more questions related to precision farming, and then I think we'll move on. There's one from Ger Snijkers. He's from the statistics office, and he was asking how satellite data correlated with precision farming data, for instance, with machines. Do you have any insights in those kind of things?
Yes, I was talking about the 3-meter accuracy of our data. This is the data which comes from a satellite, pre-corrected. And if you then use your own ground control points to auto-rectify this data, then you can get into sub-pixel accuracy. So yes, you can use these data with GPS and precision farming in centimeter. So of course, it's limited to 30 centimeter because 1 pixel is 30 centimeter. But I think GPS is also not as accurate as 30 centimeter. Maybe with some stations on the ground, you can measure it a bit better, but you can always put the pixel in these areas to use it for precision farming. And it is also used in precision farming. So we have customers buying as base layers for their farming, updating it every year or every quarter. Yeah. Not in winter though.
Okay.
Eric, I can just echo that. And as I already mentioned, so we have a huge group of clients coming from the agricultural business, and most of them are using our imagery to create map products that are being used in the precision farming context. So the spectral measurements are correlated with measurements on the ground, and yeah, that definitely can be used in this context.
Thank you. Okay, thank you very much. I would now like to continue with Elise.